Exam. Question 2 says a group of learners design a device that consists of a light ball on a string hanging from the roof of a cargo truck. This device is used to determine the acceleration of the truck. When a truck is stationary or moving at a constant speed, the ball will hang straight down. But when it is undergoing a constant acceleration, the ball hangs down at an angle theta as shown in the diagram. So, looking at this diagram, we see the truck and we see the acceleration to the left, and we see that the ball is not hanging straight down because it is not stationary. If it was stationary, it would be hanging straight down. However, because it is moving at a constant positive acceleration to the left, then we see that the ball hangs at an angle to the right from the horizontal. If there was negative acceleration, it was slowing down, then the ball will hang on the other side. We'll see that the angle is on this side or the ball hanging here. So the way we see it in this case is that the ball is hanging, leaning to the right, so the ball basically has positive acceleration. The question is, draw a free body diagram of all the forces acting on the ball. So then 2.1, let's just write down question 2. Question 2 and 2.1 says the free body diagram of all the objects, all the forces acting on the ball. If this is the ball, then we see that the string is acting upwards, as we see there. So this will be the tension on the string, or we can even say the force of the string if we want to say it that way. And then we've got the gravitational force acting downwards. This is the force of gravity acting downwards. So those are the two forces acting on the string or on the ball. 2.2. Looking at the question, 2.2 says, in this case, the mass of the ball is 50 grams and the angle is 18 degrees. Calculate the horizontal force on the ball. So if you want to calculate the horizontal force on the ball, if we're looking at this object here, then we're looking at the force acting in that direction there. So we'll have to draw a diagram. So on the question sheet, you can draw a diagram, but I'll draw it in rough here. We will say that is our pencil, and then we'll have gravitational force acting down. We'll have our horizontal force acting this way, horizontal component acting that way, then the string is acting up this way. So this will be our tension, this will be the force of gravity. And we see that the angle here will be the angle 18 degrees. So if we look at the diagram, that will be the diagram that we have. Let's just double check what we have. Calculate the horizontal force on the ball. Okay, so if we have to calculate the horizontal force on the ball on this side here, we'll see that in terms of the angle 18 degrees, if this is our angle 18 degrees that we are working with, if this is the angle 18, this is the main, then this side will be the opposite side. This side will be opposite, and this side will be the adjacent. So if we're saying opposite of adjacent, then we're looking at tan of theta. So we will look at tan of theta in our diagram. So we'll say 2.2. We should rather have 2.2 written on the next line to make it look organized. Say 2.2. We'll say the tan of theta is equals to the opposite over the adjacent. And the angle theta we're looking at will be tan of 18 degrees is equals to the opposite side, the horizontal component which we are looking at, over the gravitational side, the force on the left. And if we have to work it out here, we don't have the force, so we'll have to say work it out here. F, G, or W, you can say which is W, is equals to mg. So the mass that we have here is 50 grams, so we'll have to change that to kilograms, so it will become 0,05 multiplied by 9.8. So if you work that out, you'll see 0.05 times 9.8, and if you work it out with our calculator, we get 0.05 times 9.8 will give you 0.49. 0.49 newtons. So that will be our horizontal component here. Should be 0.49 newtons. Then if you take it further, you have to take it onto the other side. We'll say the 10 of 18 degrees multiplied by 0.49, and that will give us our horizontal component that we're looking for. And if you work it out, it's 0.49 multiplied by the 10 of 18 degrees. This gives you 0.159. So that will be our answer, 0.159 newtons. So that will be the answer for 2.2.1 that we are looking for. So the question in 2.2.1 is the horizontal component of the ball, and that will be 0.059.